So welcome friends, we would like to find the support reaction of the given beam. We have got a beam A, B. The support A is hinge support and support B is a roller support. And there are two forces acting on the beam. One is 100 Newton at point C and another is 200 Newton at point D. This 200 Newton force is inclined at angle 30 degree with the length of the beam. A beam is supported at two end points, so it is a simply supported beam. So in order to find the support reaction of this particular beam, we shall first draw the free body diagram of the beam. So since it is a simply supported beam, there will be reactions acting at point A and point B. Now if you look at here, since at point A we have hinge support, so always the hinge support will have two reactions. One is vertical reaction, another one is horizontal reaction. We have an inclined load acting over here, so the hinge point will give you vertical as well as horizontal both reactions. So at point A, which is a hinge point, will be having a vertical reaction and horizontal reaction. At point B, which is a roller support, will be having only the vertical reaction. So we'll first draw a free body diagram. So in the free body diagram, we show a particular body in the isolation and all the forces acting on that particular body. So we'll draw beam AB first. So this is beam AB we have here. Since the beam has hinge support at point A, there will be two reactions acting at point A. One is horizontal reaction and one is vertical reaction. So we have a vertical reaction at point A and we also have a horizontal reaction at point A because point A is having hinge support. This is the vertical reaction, so that is called as a reaction at A in vertical direction. So vertical I am going to call V, and reaction at A in the horizontal direction, that is called H. So we have two reactions at hinge point A, and at point B we will have only one reaction. So at point B we will be having only vertical reaction because it is a roller support. There is reaction at point B, so it is in vertical direction. Now we have forces acting at point C and D, so we will show them accordingly. So at point C we have 100 Newton force acting in downward direction. At point D we have 200 Newton force acting at an angle 30 degree inclined with the length of the beam. So this is basically the free body diagram, which shows all the forces acting on the support and all the forces which are acting on the beam. So we have drawn the free body diagram of the beam. Now since we have here an inclined load of 200 Newton which is acting at 30 degree with the length of beam, we can resolve this 200 Newton into two components. So we will resolve in the horizontal component and in the vertical component. The vertical component is 200 sine 30, which is from geometry we can say, while the horizontal component would be 200 cos 30. Now in order to find the support reaction of the beam, we shall be considering only the components of the inclined load. As we know that this beam is in equilibrium condition, so we can use the condition of static equilibrium to find the support reaction. So let's do it. So we have already discussed in our previous video about the condition of static equilibrium. So please refer that video. You can find out that video in our channel. So there I have already specified what is the condition of static equilibrium. So we have three equations. One is called as the summation of forces in the vertical direction is 0. So vertical direction we are taking as y. So all summation of forces in vertical direction, and that is we call summation of forces in y direction 0. So if you look at here, in vertical direction we have force RA vertical 100 Newton downward, 200 sine 30 downward, and then RB, which is the reaction at point B in upward direction. So these are the vertical forces acting on the beam. So algebraic sum of these forces must be 0. So as already we have discussed, we take sign convention. The upward forces we take positive and downward forces we take negative. Therefore, you will be getting from here RAV, which is the reaction force acting at point V in vertical direction, which is plus. This is going to be plus because it is upward direction. 100 Newton is acting downward, so it is minus 100 Newton downward direction. 200 sine 30 again downward direction, minus. This is also downward direction. And RB, which is acting upward direction, it is positive, plus RB is going to be 0. So from here we can simplify this equation and we will get RAV plus RB equals, all these things will go towards right. So 100 plus 200 sine 30. Sine 30 is 1 by 2. So if you calculate that, sine 30 turns out to be 1 by 2. So it is 200 into 1 by 2. So 100 plus 200 into 1 by 2, and then that whole thing would be simplified as RA vertical plus RB equals 100 plus 100, that is 200. So this is our first equation. Now, so the second condition is, since the beam is in equilibrium condition, the summation of forces in the horizontal direction would be 0 in the horizontal direction, that is, so all the forces in the x direction we can say 0. That would give you, now here also we take sign convention, towards right direction of the forces we take positive and towards left we take negative. You can take vice versa also, but here I am taking, so in the right hand direction we have RAH, that is positive, so it is towards right, and we have 200 cos 30 which is towards left, so minus 200 cos 30 which is towards left, so it is taken as negative, and that turns out to be 0. So if you simplify this, so you get RAH as 200 cos 30, so it is 173.20 Newton. So this is our equation 2. So since beam is in equilibrium condition, summation of moment of forces about any point will be 0. So we should take a summation of moment about a point where unknown quantities are acting. For example, RAV and RB are the unknown quantities. So we can take moment about point A or we can take about point B. So we can get a single unknown in that equation and then we can solve for the another unknown. So let me take about point A. So summation of moments for point A I am taking. If you look at here, so this beam is going to rotate about point A. When 100 Newton force will act at point C, it will tend to rotate beam in the clockwise. So clockwise we take positive. So the moment is going to be 100 times distance AC, and that is 3 meters. So 100 into 3 meters is the moment which is clockwise. So clockwise is taken as positive. Now similarly, 20 sin 30 would rotate the beam in the clockwise direction when it is going to act at point D. So the moment would be 20 sin 30 and the distance from point A is AD, which is 3 plus 3 6. So 20 sin 30 into 6. Again it is going to rotate clockwise, so it is plus. Now as far as 200 cos 30 is concerned, it is acting in the direction along the length of the beam. So when it will act along the length of the beam, it is going to pass through the point A, about which we are finding out the moment. So when a force is passing through the point, its moment is going to be 0 because distance from that point will be 0. If you look at that, all the forces which are passing through the given point about which we are finding out moment will have 0 moment. So that moment of the force 20 cos 30 will be 0. Similarly, the moment of force RAH about point A is 0, RAV about point is 0 because they are passing through the same point. So we will have only moment of force 100 Newton and moment of force 200 sin 30 and moment of force RB. So what is RB? RB is going to rotate the beam in the anti-clockwise direction like this. An anti-clockwise moment we have taken as negative. So it is going to be minus RB. The distance of RB from point A is 3 plus 3 plus 4, that is 10. So this has to be 0. So if I simplify this, you will get 100 into 3 is 300. 200 sin 30 is going to be, sin 30 is 1 by 2. Sin 30 is 1 by 2. So 200 into 1 by 2, that is going to be 100. 100 into 6, 600. So plus 600 minus 10 RB. So that will turn out to be 10 RB. If you simplify this, that is 900 equal to 10 RB. So RB is going to be 900 divided by 10, and that is 90 Newton. Got the value of RB, that is reaction at point B, as 90 Newton. So if you substitute the value of RB in equation 1, which is RAV plus RB equal to 200, and that will give us RAV plus, that is RB is 90 equals 200. That would give us the value of RAV, which is vertical reaction at point A, as 200 minus 9, that is 110 newtons. So this way we are able to find out the support reaction at point A and point B.